Lesson 2 is on the properties of the elements. We're going to be describing the properties of metals, nonmetals, and metalloids.
So when we look at metals, metals are what we call malleable. And malleable means that metals can be hammered or flattened into what we call sheets. Like a sheet of paper, you can have a sheet of metal. Metals are also ductile, means that metals can be stretched or drawn into a wire. Think of your iPhone or your Samsung cables. They're full of wires because metals are ductile. Metals are also highly conductive, hence why they are great at sending heat or electrical energy throughout them.
Which is why you don't want to put them in the microwave.
Yeah, if you put, let's say, metal in a microwave, you'll see electricity in the form of lightning occurring inside the microwave. And somebody at home will probably get really mad at you. Metals also have what we call a luster. Luster is just a bright shine when a metal is being polished. And they have a charge. Metals will always lose electrons and they will always form positive cations.
Let's repeat that. Always lose electrons and form positive cations.
Gotta know it.
In regards to malleability and ductility, the reason why metals are able to do this is because their atoms can actually slide over each other since there is a sea of electrons.
So for example, if you're looking at the GIF that's animating, as that block comes down, the actual atoms just move out of its way. They're still stuck to each other through electromagnetic forces, but they just move because they have that free ability to. Alloys are going to be very strong because they're actually physical mixtures of metal that have been melted, mixed, and then eventually cooled. So alloys are mixtures of metals, and they are stronger because of the fact that they have the ability to stop that sliding factor.
So steel, bronze, those are examples of alloys.
And if you were to look over at this diamond over here, you'll see that we have different types of metal that are going to be in your gold. So if you have a lot of gold, it's going to be a yellowish red color. A majority would be that. If you start to add more silver, then you're going to get things like white gold, which is over here. Or if you took your gold and added some copper, it's going to turn reddish. Any type of gold or white gold or sterling silver is what we call an alloy. It's a mixture of metals.
So why do metals have this shine to them? Metals are easily able to absorb light energy, which excites the valence electrons. And as those electrons fall back to ground state, they emit that light or luster, so that shine to it.
But what happens if you have like a spoon and it's all like dirty looking? Why doesn't a dirty spoon shine?
There's some corrosion probably on that dirty spoon. So
what's corrosion though?
So corrosion is when we have a compound on top of the metal that's underneath. So that's why you have to polish your silverware to get that compound off.
So why are metals really conductive? So metal atoms will actually freely share electrons with each other. As Ms. Diamantopoulos said a second ago, they have what we call a sea of mobile electrons, which allows those excited electrons to transfer energy throughout the entire sample. So if you looked at the picture on the right, the electrons are not bonded to any particular atom and are free to move around in the solid. So if you were to add a charge to the far right-hand side, the electrons on the far left-hand side would either be attracted or repelled to that charge. That's what we call a current. Or if you were to heat up the left-hand side, the heat would travel all the way to the right-hand side until the entire sample is uniform in temperature.
So who is the most metallic element on the periodic table? That would be francium because it is the most metallic element. The further away from francium you are, the less metallic properties you have.
So if you were to look at oxygen, which is on the other side of the periodic table, it's not going to be very metallic because it's really, really far away from francium.
Right. So properties of these nonmetals. Nonmetals are brittle when they are solid. So that means that they will shatter when struck. Their luster is very little. They're very dull. They do not conduct electricity or heat very well. Some can conduct electricity, but not to the extent of metals. So now when nonmetals turn into ions, they will always gain electrons and form negative anions. Again, they will gain electrons during a chemical reaction and form negative ions.
You have to know this. So who is the most non-metallic? In this case, it's going to be fluorine in the top right-hand corner. Fluorine is the most non-metallic element. And the further away you get, the less non-metallic it becomes. So if you were to look at cesium, which is CS on the far left-hand side, cesium is very metallic and not at all non-metallic.
Notice that we left group 18 out of this. That's because they're not reactive. So we're not really discussing them as metals and nonmetals in that aspect.
We also have what's called metalloids, which fall on this very peculiar spot of the periodic table. So metalloids are brittle, which means that if you hit them, they will shatter.
Just like nonmetals.
But they also have a luster, which means that they're shiny.
Just like metals.
They're conductive, which means that they do allow heat and electricity to flow through them, but not as well as metals.
But better than nonmetals, right?
But much better than nonmetals.
Yeah.
And they also have the ability to have a variable charge. So metalloids can either be positive or negatively charged. Metalloids have that unique ability to become anions or cations. You have to use your periodic table, and looking at the charges, it will tell you if it's lost or gained electrons. So, looking at your periodic table, you should probably mark down the different metalloids. You have boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Maybe you should put a star in the bottom right-hand corner. Something so you remember that those are the metalloids.
Metalloids always land on that heavy stair step that you see on the periodic table.
Hence why it's bolded. It's already done for you. So looking back at our information that we've presented, these are the facts that you need to know about metals, nonmetals, and metalloids.